Hello friends, in this tutorial we are going to learn about binary trees. In the previous tutorial we got to learn about what is a tree, how we represent the tree and what word tree is used, all those things. So in this tutorial we will learn about binary trees. Binary trees. Binary means 2. That means it should have at most 2 children. At most 2. If it is at least 2, then must and should 2 and more than 2. If it is at most 2, either it can have 0 or it can have 1 children or it can have 2. 0, 1 and 2. Only these 3 possibilities are there. If it is at least 2, it should be 2 or greater than that. For binary trees, how we represent 1, 2, 3. This is correct. 1. No children. This is also correct. 1, 2. This is also correct. This here 0. Here 2 children are there. Here 0 children are there. Here 1 children is there. Here 1 children is there. No children. Nothing. This is also correct. We can represent the binary trees like this. Either 0 or 1 or 2. Now let's check what is height of the tree and what is depth of the tree. Let's consider a tree A, B, C, D, E, F, G. If we say depth of the tree, let's take depth of A is 0. How we say depth of A is 0? How can we say depth of A is 0? When we have these many nodes associated with A, because depth goes backside. It checks whether it have any parent or not. So depth of A is 0. Depth of B is 1. It have A. Depth of C is 2. It have B and A. Depth of D is also 2. It have B and A. Depth of E is 1, 2, 3. And depth of F is 1, 2, 3, 4. Depth of G is 1, 2, 3, 4, 5. This way we calculate the depth going backside. Now height of tree. How we do this height of tree? Depth goes back, height goes down. Now height of A is 1, 2, 3, 4, 5. We choose the more height thing. Here A, B, C. But this is also one height. That is 2 is the height of A. And 1, 2, 3, 4, 5. 5 is also height of A. But we mostly choose 5 because height should be more. Now height of B is 1, 2, 3, 4. Height of C is 0. Height of D is 3. Height of E is 2. Height of F is 1. Height of G is 0. This way depth we go back, height we come down and see. For the most height and most depth. Binary representation is like this. Height and depth we calculate like this. And what is the level of this tree? Level 0, level 1, level 2, level 3, level 4, level 5. Level of the tree is level 5. And now we have internal nodes and external nodes. What are internal and external nodes? Internal node is nothing but non-leaf nodes. Non-leaf nodes. That is, non-leaf nodes are nothing but which will have children. External nodes are nothing but leaf nodes. That is, which will not have children. Now 1, 2, 3, 4. Here 1 is non-leaf node or internal node. 2 is non-leaf node or internal node. But 3 and 4 are leaf nodes or external nodes. That is, 3 and 4 doesn't have children. and 1 and 2 have children's. This is what called internal and external nodes. And now, based on left and right trees in a binary tree, based on left and right trees, left and right nodes of the trees, it is classified into 3 types. One is strict binary tree, one is full binary tree, and another is complete binary tree. So how we know whether it is strict binary tree or full binary tree or complete binary tree? First, let's take example for strict binary tree. A, B, C, D. This is not strict binary tree. How we say this? Because if it is a non-leaf node, that is which is internal node and which have children, it must have left and right nodes for sure. But it only have left child. It doesn't have right child. So this is not strict binary tree. A, B, C. This is strict binary tree. A, B. This is not strict binary tree because it does. A is a non-leaf node. A is non-leaf node, but it doesn't have right child. It only have left child. So if it is a non-leaf node, it must have a left and right child. Then only we say that it is a strict binary tree. Now full binary tree. A, B, C, D, E. This is not full binary tree. Why? Because this is a strict binary tree, but this is not full binary tree. This is strict binary tree because this is a non-leaf node which you have left and right child. But this is not full binary tree because this is not balanced. That is C and C should also have 2 children. That is F, G. If all the nodes are present, we say that this is full binary tree. For example, A, B, C, D, E, F. This is not full binary tree because another node is not there. So full binary tree which should be balanced. It should be balanced. Strict binary tree, if it is a non-leaf node, it must have right and left child. But for full binary tree, the level should be balanced. Now let's go with complete binary tree. A, B, C, D, E. This is not complete binary tree. Why? Because in complete binary tree, if it is a non-leaf node, it must have left child. But C doesn't have left child. Now A, B, C. This is strict binary tree, full binary tree as well as complete binary tree. Strict binary tree because it is a non-leaf node, it have 2 children. Full binary tree because it is balanced. It is complete binary tree because it have left child. A, B, C, D. This is not a strict binary tree, this is not full binary tree, this is not complete binary tree. Because full binary tree must be balanced, complete binary tree must have left child, strict binary tree must have 2 children. So it is not strict, complete, full. In this way, binary trees are classified into strict, full and complete binary tree based on the left and right children. Now, how we represent these binary trees? We can represent these binary trees in 2 ways. One is array, another is linked list. Arrays and linked list representation we already know. Suppose let's take A, B, C, D, E. In array A, B, C, D, E, we know. Easy thing, right? Because we know it since childhood. Now linked list. How we represent this in linked list? A. as it is binary tree. C. D. E. This is null, this is null, this is null, this is null. Because it doesn't have children, it doesn't have children. If it is a non-leaf node, it will have children, then it will not be null. That is, it will have address of this children. It will have address of this children. If it is a leaf node, they are represented as null. If here one more node is there, we can represent it. Now this is null, this is null, this won't be null. So in this way represent it as linked list. So in this way we represent the binary tree in the form of arrays and as well as linked list. If it is binary tree, represent like this: A, B, C, D, E. This same thing we represented it as array as well as linked list. So in our next tutorial we will learn binary tree traversals. Traversals, how the flow goes on. That we will learn in the next tutorial. So if you like this video, please do like, comment, share and subscribe the channel, and please do click on the bell icon so that you will get to know about the new notifications of new uploads. Thank you.